A vector just represents a movement, so my first vector, which is the unit, which is u, is 9I minus 40j, and I and j are opposed at 90 degrees. So basically that means that I start somewhere, I go 9 across and 40 down. So that way is 9, that way is 40. And here's my vector here. It represents that movement, and it's usual with vectors to put an arrow on it. And this is the vector v. Now the notation we've been given there is this mod v. And it basically means the length of that vector. And because I and j are 90 degrees opposed, I can use Pythagoras to do this, but one bit of notation, I tend personally not to write i's and j's, so my vector v I'd write as a column vector as opposed to a position point in 2 dimensions. Goes 9 across and 40 down. Now we know that it's fairly obvious, and by Pythagoras here, that the length of that particular vector is going to be the square root of 9 squared plus minus 40 squared. And some of you might actually recognize this as being a Pythagorean triple. Most people recognize the 3, 4, 5, and if you look at the other vector that we got, this one's actually u, not v. Anyway, so it helps to read the question, doesn't it? 9 squared, of course, is 81. 40 squared is 1600, and that gives me the square root of 1681. And that, if you check, is 41. Now technically, because it's plus and minus, because it's a square root, and we should always have two responses to a square root, plus and minus, then this really should be plus or minus 41 units. Now really the 41 units means that if I measure it from one way, minus 41 is going back the other way. And it doesn't really make any difference because we're interested in the magnitude of this vector, the length of this vector. It's 41 units. So we always consider modulus, length, magnitude, whatever you want to call it, to be a positive element, and that's important. My other vector, now that I've read the question and know which one I'm talking about, will be the square root of 3 squared plus minus 4 squared. And the more astute of you will have realized that that's a straightforward 3, 4, 5 triangle. If you think about all the Pythagoras you've done, lots and lots of times you get multiples of 3, 4, 5. So this is 9 plus 16. So therefore this is the root of 25, and the root of 25 we know is 5. Now what we're interested in this particular question is where we've got some multiplier times the length of v is equal to, is greater than the length of u. Now this is where the bit I've said, these are positive lengths, and so therefore times 5 has got to be greater than 41, and because it's positive I can divide both sides without worrying about any effect on my inequality, my greater than symbol. You know with inequalities that you can add and subtract without changing the equality. You can multiply and divide, but only if the things are positive. If they're negative, then multiplication or division changes your inequality. But in this particular case, we've got that mu is greater than 41 over 5. And if you want to call that 8.2, that's fine. I don't mind. But 41 over 5 would do me as an answer. So as long as mu is anything greater than 41 over 5, the length of the v vector will be greater than the length of the u vector. And that's those first three marks. If we move on to the next question, point C has a position 11 minus 4. So A has a position vector 11 minus 4. Now what that means is measured from an origin. And I always like drawing diagrams in these particular cases. I'm going 11 across and 4 down. So this is my A vector. And B has a position vector 21i plus j. So it's going to go 21 across. I need to make this line longer, but it's not going to go up very far. So here's my B vector. Goes across 21. And I'm going to put these in as vectors 21, 1. And this one is 11 minus 4. Now, we've got a position vector of a point C. So it lies between A and B, so that the ratio is 2 to 3. Now, clearly that means that C is somewhere on this line here. And it's closer to A than it is to B, because the ratio is 2 to 3, and the A to C bit is smaller than the C to B bit. So this is where my C is. Now, a whole bunch of different ways of doing this, but I quite like the simplest way. I only ever tend to think in simple ways. I don't think we should ever make things hard. And that's in terms of similar triangles. I mean, so there has to be a point of learning all these similar triangles when we were at GCSE. So if my point A is at 11, 4, because that's where my vector takes me, and my B is at 21, 1, then if I put in the movements vertical and horizontally, if I go from 11 across to 21, starting at 11 and going across to 21, clearly I'm going across 10. If I start at minus 4 and go up to 1, I'm going up 5. So this vector that runs from here to here is the vector 10, 5. But I'm interested in where it's split. And we know that the ratio that we're using is 2 to 3. Now, last time I checked, 2 plus 3 gives me 5. So I want to split my vector into 5 equal bits. So that means that what I'm interested in is 2/5 of the way up. And that's A to C. So it's going to be 2/5. Now the triangle has got to be similar because the angles are the same. So 1/5 of this side is equal to 2, so my 2/5 has got to be equal to 4. 1/5 of this side is 1, so 2/5 has got to be equal to 2. So what I'm doing is I'm starting from 11 minus 4. I'm going across 4, so I could do it this way. 11 minus 4 plus 4, 2, because that's my next movement. That gives me 15 minus 2, which more or less fits with my diagram, but diagrams don't have to be fantastic. So it wants the position vector. Now there is the position vector of C. So if I wanted to be ever so clever, I could say, right, OC, because I started with an origin O, is the vector 15 minus 2, which is exactly the same as writing 15I minus 2j. There's my answer. I personally would write it that way, but it doesn't make any difference.